Hi, Professor. I'm Ruchita Reddy Koluguri from Geek Squad team. My team members are Suresh Ravuri, Harshavardhan Valmiki, and Sri Vinay Appari. I'm going to discuss about a midterm exam project, which is about the real estate investment analysis. Let's first discuss about the project description. Here, the real estate represents a tangible asset that can yield a consistent income stream from the rentals and grow in value over time. Investing in the real estate, which also offers the potential tax advantages, including deductions on mortgage interest, property taxes, and depreciation. However, it's very crucial to consider the risk like the market value, property damage, tenant complications, etc. Now here, our main business case is like the objective is to guide the investors toward purchasing the properties where the combined expenses of the homeowner association fees, that is the HOA fee, and the mortgage payments should be less than the rental income. Like this ensures the investment generates a positive cash flow, which maximizes the return on investment, the ROI value, like both to the intermediate rental income and the potential future appreciation in the property value. Here, by leveraging this data analytics, we aim to categorize the properties into three types: the least, most, and more desirable, based on their ability to meet the investment goals. Here, taking into account the factors like location, property features, and the market trends, this strategic approach will enable investors to make informed decision about the alignment with their financial aspirations and investment portfolio. We have already mentioned about the key discussions in the story in the write-up. Now let's go to the okay. Here first we have taken the initial data set which is provided by the professor. We have loaded the data set and let's take a look at some of the features: rank, property ID, location, price, number of bedrooms, the area, and like number of days the property present on the Zillow, and the pictures, the broker name, etc. Now let's look at the data preparation. Here, data preparation is a very important step in the analytics process. Here, we just clean the data where we identify and correct the errors and remove the duplicates, missing values, and address the outliers. Here, the next steps such as normalization, scaling, and the categorical encoding values and feature engineering are applied to make the data compatible with the analytical methods. And the first on the first data set, EDA is applied, and we can take a look at the columns and the description about them. And we have checked null values for the data set 1. There are few null values in this data set, and we perform the cleaning steps on it. There is no data in the sold date column, so we have removed it. Then coming to the currency, like all the values are present in the US dollars. So we have removed the currency column, which is of no use. Next, we have added the street, city, state, and zip columns from the listing URL because like it contains all the details in the form of URL. But we have converted the URL to the columns. Next, and like some of the area metrics are mentioned in square feet and them are mentioned in the acre. So we have converted everything into one format. Yeah. Now you can see here that like all the missing values are removed from the data set. And next the plotting and correlation is done. Here, the correlation ranges from -1 to 1. Like a value of 1, the positive plus 1 indicates a perfect correlation, meaning that one variable increases, the other variable increases proportionally. And the like a value of -1 indicates that a perfect negative correlation. It means as one variable increases, the other variable decreases proportionally. And the 0 indicates a no correlation between the two variables. And we can take a look at this graph where the longitude, latitude, and the rank, like everything is one in a row and a column for each variable, indicating that each is perfectly correlated with itself. And like simply other variables like the price, we can take a look at the price. Here, the price exponentially increases with respect to the number of bathrooms and the area. Like if the area of the house is less, then the price relative to the area will be less. And coming to the histograms, here we have created some histograms for each numerical column in the data frame. And the above box plot shows that like the price, bathrooms, property ID has the outliers here. You can take a look at the outliers which are present in these. And like they are right skewed with the mean finely skewed too. And let's take a look at the second data set, which contains the year which the property have been built at, and the stories and the square feet of every particular room or every particular area in the house. We have scraped this data set, and we also perform the EDA steps on this. And like there are few missing values in one of the columns, and we have cleaned it. And we have removed some of the unnecessary columns which we haven't used or which are not very useful, such as like the carport square feet, livable square feet, like which doesn't make the more sense or the more value to the accuracy of the project. So we haven't used this. And coming to the correlation and plotting here, and we have done the same correlation between all the columns mentioned in the dataset too. And same the histograms are plotted here. Yeah. And coming to the data amalgamation, here we have stripped the third data set, and the first amalgamation is done on the data set 1 and 2. The data set 1 is the one provided by professor, and the second one from the scraped is a scraped data set. Here, let's take a look at the Gini score index for the feature importance. Here, like it's let's discuss about it brief, like what we have done here and what we have seen in the. Let's take a look at the decision tree. Here, like the nodes, each box is a node that makes a decision based on one of the features of the data set. For example, the top node, which gives the data based on the rent Z estimate feature. And the branches, the lines connecting the nodes present the flow of the decision process. The left branches typically represent a no or a false decision, and the right branches says a yes or a true decision to the question posed by the each parent node. And coming to the Gini index, the Gini value in each node measures the impurity of the node, or like how mixed the classes are at that point in the tree. A Gini index of 0 indicates that all the cases in the node fall into a single category, while Gini index close to 1 indicates that cases are evenly distributed across the categories. We can look at the multiple Gini scores here in all the nodes. And coming to the samples, like this tells us how many samples are being considered at the node after the split was made by the preceding node. And the value of the array in each node says that it indicates the class distribution of the samples. Like if you are dealing with a binary classification, we can typically see the numbers in the array. For the other multiple class classification, the array will be longer. Here, the decision tree is a visualization of how the model makes decision. It splits the data into subsets based on the value of the features, trying to isolate the samples from the different classes in separate branches of the tree. From this tree, we can infer the most important features that the model is using to make the decisions. Like the first split in the tree was like the typically the most important decision, which indicates the rent z estimate and the area are the significant predictors in this model. Let's take a look at the work we have done previously regarding to Guinea. Here we have dropped few columns which are unnecessary, and like if there are missing values, we have filled with the respective mean and median. Yeah. And like finally all the missing values are clean, and we have performed the train and test on this. And the next the feature importance is we have find out this regard by the decision tree. Next we'll take a look at the feature importance. Here the most important features are the rent z estimate and the area. Like we have also seen these two values are important in the decision tree itself. And go let's scroll down. Yeah. And here we have a plot which says which is between the price and the area. Here the function, and like we have plotted some of the graphs related to bedrooms count. Here the three bedrooms houses are like the most popular, and this shows that most buyers are interested in the houses which are like three bedrooms and two bathrooms with the price range of 400 to 500k. Like the average buyer interested houses are priced around 600k, and like some most of the houses with bedrooms more than five are not very preferred. And we can take a look at the bedrooms distribution. The purple one indicates the three bedroom which has the highest. Now let's take a look at the classification. And we also worked on the SHAP. Here, the SHAP function is also called to display the plot that summarizes the SHAP values for each feature in the dataset. While next, here we have mentioned few of the functions which we will be using later for the Muller loop classification and regression. We have just defined those functions here. Let's take a look. Some of the functions here are related to the Muller loop for classification, which are defined here. And next we have used the other functions related to the regression here. And we'll be using these functions later in the collab. And the other functions related to the fractal distance calculation, k-means with fractal distance, and the k-means with Euclidean. Okay. Now we'll take a look at the latent variables. Here we scraped a beautiful dataset consisting of the predominant latent variables, which can be the form factors while choosing the right house. These latent variables predominantly act as a characteristic feature for houses, which indirectly may impact on the popularity, like the pricing and other considerations of the house of the location. For the location, we scraped walkability, mix of employment types in a block group, like they such as retail, office, industrial, and percentage of workers that are low, medium, or high wage, like by home and work locations. And there are like many other latent variables which are not that necessary. And like we are adding these latent variables to our initial data set one. Yeah, this is our initial data set, and we have added the latent variables to that. And like next, we are adding these latent variables to the amalgamated data set. This is amalgamate data set, and the latent variables are added to it. Next, we are implementing the machine learning algorithms here. Now, like we'll define the golden cluster and the use of fractal clustering to find it and like the to train and apply the algorithms. Here we use a Muller loop for the classification and regression. We have used some like five algorithms and for the regression and seven for the other one to compare the relevant tasks in the same table. The first thing is the fractal clustering with Euclidean distance. Here we have dropped few columns which are not necessary. And in the first iteration, here the elbow method within the cluster SSC, the first plot is likely an elbow graph that shows a within cluster sum of squared errors for different number of clusters. This is a very common method for selecting the optimal number of clusters. And the next one is silhouette score. Here, this is done after k-means clustering. It shows for the scores for different number of clusters. The silhouette score is a measure of how a similar object is to its own cluster or own cohesion, like compared to the other clusters or the separation. The silhouette score ranges from -1 to 1, like where a high value indicates that the object is well matched to its own cluster and the poorly matched to the neighboring clusters. We can take a look at the performance after the clustering. Here, the silhouette score is 1, which is a perfect and indicates that every point is exactly on the border of the nearest cluster. This usually happens like in very distinct or good separated data. And next, SSC within cluster is a little large, and this represents the sum of square distances between the each method of cluster and cluster centroid. Here, the lower SSC value suggests that model has few errors and the clusters are tighter, but we got a little higher SSC value. So we'll perform this again, like we'll do a second iteration. And here we see that after the first iterance, there is a one predominant cluster, and hence we have to perform the second one on this cluster. Then we have performed the second iteration. Here, after the second iteration is done, the golden cluster is formed. Like within the information provided, it seems that the cluster one with the good data points is larger than the cluster zero. So we consider it cluster one as a golden cluster. Coming to the fractal clustering with the fractal distance. Here we have plotted the graph for fractal clustering with fractal distance. Previously, we discussed about the Euclidean distance. Yeah, here the Silhouette score, for the first iteration, we found that the Silhouette score is negative, which is not very preferred. So we have performed the second iteration on this with different number of clusters. Then we got a positive value. Here, the positive value is preferred, so we'll be stopping with the second iteration. Then the classification using Muller loop is done here. We have previously discussed about the functions which we'll be using in this Muller loop classification and regression. Now we'll be using those functions here. And coming to the dataset 3 here, uh, like the homeowner association for classification is added, like for further in-depth investigation of house pricing and looking for some correlating factors, we have introduced a HOA and the mortgage to our data set. These are basically to calculate the appreciation trends of the property, pre-released property. On investigating, we came to the conclusion that the least interested houses are the houses with high price and mortgage fees. This reflects that irrespective of the spatial features of the houses and the latent variables, unreasonable pricing causes the buyers to neglect that type of housing options. We have performed some of the data cleaning steps here to remove the missing values, and here we found out the mortgage fee using a formula. Then we have added the HOA and mortgage here in our data set. Now the classification is done on this, and the results of the classification are here. From all these algorithms, we found out that the best one is the linear SVM with a great accuracy of 99.4. Then the amalgamation is done. Here, the amalgamation in the context of data analysis and the management, which refers to the process of combining or merging the multiple data sets or the information sources into the single one, the cohesive data set. This process is very essential when dealing with the data from different sources or formats, like to ensure the consistency, eliminating the redundancies, and enhance the completeness of the data. Amalgamation involves several steps, including the data cleaning to remove the inconsistencies, errors, data integration where the related data from different sources are logically combined, and the data transformation to ensure the uniformity in the format and structure. Finally, the goal is to create a comprehensive data set which provides a unified view, facilitating the deeper analysis, improved data quality, and more accurate insights. So now let's take a look at the dataset which is amalgamated. Here, after the amalgamation is done, then we have performed the classification on it using the Muller loop. And after this, the best classifier, the best algorithm is AdaBoost with a almost 100% accuracy. Coming to the dataset one with the latent variables, here we'll be adding the HOA to it. Let's take a look at the dataset after adding them. Here we have added the first dataset with the latent variables, and we have added the HOA and mortgage dataset to it. So like the amalgamation is done twice here, and we have performed the classification again, and the best classifier here again is the linear SVM with a 98% accuracy. And then the amalgamation is done with the latent variables and adding the HOA is done again. And the best classifier is linear SVM with 99 accuracy. And the classification is part is done now. And like we'll be working on regression now. Here, first we have done the regression on the initial dataset 1, which gives a gradient boosting regressor as the best algorithm with 70% accuracy. Then we'll be doing regression on the amalgamated dataset. Then we got the accuracy as 80 for the best algorithm gradient boosting. Then the next regression is performed on the dataset 1 plus the latent variables. Like we have added these two, like we have amalgamated these two datasets and performed a regression on it, which gives a 76% of accuracy as the highest for the linear regression. Then for the amalgamated data set, again, we have added the latent variables. Like this amalgamated data set contains the 1 and 2, data set 1 and 2, and we are adding the third data set as the latent variables. And here the performance is 72 for the random forest, which is the highest among all the regression algorithms. And coming to the overall metrics, here for the classification, we have displayed all the metrics in the form of a table. This is for the dataset 1, and the next one is about the dataset 1 and latent variables. So on for the amalgamated one and the amalgamated one with latent variables. So we have displayed all the metrics in a table format. And for even for the regression, we have done the same thing. Dataset 1 and like the amalgamated one with latent, and the amalgamation is done here. Sorry. Yeah. And like the final part here, we are creating and saving the best performing models. For the classification, we have saved the model in the pickle file. Here the model predicts the three classes, the least, most, and more desirable one. So that we can use this model without retraining it. So we have saved it in the pickle file. And even for the regression, we have done the same thing. We have loaded and saved the model. Thank you. And let's look at our research IEEE format team paper for our Team Geek Squad. Here we have first added the abstraction part and a little introduction about our project, and the data narrative. Okay, a data narrative is done for the initial data set 1 and the data set 2, which is scraped, and the data preparation, EDA on like all the data sets which are provided, the data amalgamation, feature importance, and like all the things we have discussed earlier in the collab, we have applied all this in the paper. The Muller loop for classification, regression, and the clustering using the fractal distance, and the k-means clustering using fractal distance and the Euclidean distance. And we have added the latent variable dataset, which is scraped, and we have amalgamated with the initial datasets, and the results are displayed here. Yeah, and the like overall metrics are displayed in the form of tables. Yeah, this is all about a project and the IEEE paper. And coming to the work distribution, myself and Suresh worked on the data scraping part, and Harshavardhan and Vinay worked on the data preparation, like which and the like EDA data cleaning and like plotting and correlation part. And coming to the data amalgamation, I worked on the amalgamating part of the one first dataset and second dataset, and worked on Guinea sharp score. Suresh worked on amalgamating the next datasets like for the latent variables and like adding these latent variable dataset to the dataset 1 and 2. And coming to the next implementation of the machine learning algorithms, here were the fractal clustering with Euclidean distance and the fractal clustering with the fractal distance we have worked on. I worked on this part, and I have also worked on the classification with Muller law. And the Suresh worked on the regression part using the Muller law. The classification part and the Muller loop which also contains the dataset 1 to HOA latent variables. Vinay worked on adding the regression part, the adding the amalgamated one with the latent variables. And Harsha also worked on adding the HOA part to it. And we combinedly worked on the metrics part for displaying, and like we have added the save pickle, we have created and saved the best performing models. Thank you.